SDN, Software Defined Network. Software Defined Networking, SDN, is a modern network architecture that moves the brain of the network into a centralized software application. In traditional networking, every router and switch makes its own independent decisions about where to send data. In SDN, these decisions are made by a central SDN controller, which then sends instructions to all the devices in the network. This shift makes the network programmable, agile, and much easier to manage at scale. Key concepts of SDN. To understand how SDN works, you have to look at how it breaks the network down into specialized layers and interfaces. 1. The planes, control versus data. The most fundamental shift in SDN is the decoupling of these two functions. Control plane, the brain. This is the part of the network that decides how traffic should flow. It handles the logic, calculating routes, enforcing security policies, and managing traffic loads. In SDN, this plane is moved from individual hardware devices into a central software controller. Data plane, the muscle, also called the infrastructure layer. This consists of the actual hardware, physical or virtual switches and routers. Its only job is to receive packets and forward them to the next hop based on the specific rules provided by the controller. 2. The SDN controller. The SDN controller is a software application that acts as the strategic center of the network. It has a bird's eye view of the entire topology. Because it knows the status of every link and device simultaneously, it can optimize traffic in real time, such as rerouting data away from a congested link before a failure even occurs. 3. Southbound interface, SBI. This is the communication bridge between the controller and the networking hardware below it. Role: the controller uses the SBI to push forwarding rules down to the switches. Common protocol: OpenFlow was the original standard, but others like Netconf and P4 are also widely used today. 4. Northbound interface, NBI. This is the bridge between the controller and the applications or business logic above it. Role: it allows network administrators or automated programs, like a cloud orchestration tool, to tell the network what it needs. Example: give this video stream high priority. Format: these are typically RESTful APIs that allow developers to write code that automatically configures the network. Network virtualization. One of the most powerful results of SDN is network virtualization. Just as server virtualization allows one physical server to run multiple virtual machines, network virtualization allows you to create multiple virtual networks on top of a single physical infrastructure. Abstraction: it hides the complexity of the physical hardware, cables and ports, and presents a logical view to the user. Multi-tenancy: a single physical network in a data center can be carved into hundreds of isolated virtual networks for different customers, each with its own addressing and security rules, without any of them interfering with each other. Summary table: traditional versus SDN feature. Traditional networking, SDN, software defined, control logic distributed, on every device, centralized, in the controller, configuration manual, device by device, automated, via API/controller, flexibility static and rigid, dynamic and programmable, visibility limited, per hop view, global, entire network view. SDN architecture. The architecture of a software-defined network, SDN, is built on the principle of decoupling the system that makes decisions, the control plane, from the system that forwards data, the data plane. Standardized by the Open Networking Foundation, ONF, this architecture is typically organized into 3 distinct layers connected by specific interfaces, APIs. 1. The 3 layers of SDN. Application layer. The top layer consists of software applications that define what the network should do. These are not just web apps, but specialized network services. Examples: load balancers, firewalls, intrusion detection systems, IDS, or analytics tools. Role: applications communicate their resource needs or security policies to the controller. For example, a video conferencing app might request a high priority path with low latency. B. Control layer. The SDN controller. This is the brain or the network operating system, NOS. It is a logically centralized software entity that maintains a global view of the entire network. Role: it takes the high-level intent from the application layer and translates it into specific, low-level instructions for the hardware. Logic: the controller calculates the best routes, manages traffic flows, and ensures that security policies are enforced across all devices simultaneously. C. Infrastructure layer. The data plane. This layer consists of the actual networking hardware, which can be physical or virtual. Devices: SDN-enabled switches and routers. Role: these devices are dumb in the sense that they no longer make independent routing decisions. They simply follow the instructions, flow rules, provided by the controller. For example, if a packet arrives from port 1 with IP X, send it to port 4. 2. The interfaces, APIs. The layers communicate through 2 primary types of interfaces that act as translators. Northbound interface, NBI. This connects the application layer to the control layer. It allows developers to program the network using standard APIs, typically RESTful APIs. This is what makes the network programmable. Southbound interface, SBI. This connects the control layer to the infrastructure layer. It is the protocol used to push instructions down to the hardware. Common protocols, OpenFlow is the most famous, but others like netconf, P4, and gRPC are also widely used. 3 key architectural benefits: centralized intelligence. Instead of managing 100 routers individually, you manage one controller that automatically updates all 100 devices. Agility. You can change the entire network's behavior by simply updating a piece of software, rather than manually reconfiguring hardware. Hardware abstraction. Since the controller uses standard southbound protocols, you can mix and match hardware from different vendors, Cisco, Juniper, Arista, and manage them all through the same interface. Summary table component. Analogous to primary function application layer, business strategy defines network behavior and policies. Northbound API language/interpreter allows apps to talk to the brain. Control layer. The brain centralizes logic and calculates paths. Southbound API nerve system sends commands to the muscles. Infrastructure layer. The muscles forwards packets based on rules. How SDN works.